Good. Briefly introduction to my person. My name is Reiner Zitzmann. I'm going to present you today some small insights of the CleANopen protocol. So giving you an idea what means CleANopen, how is CleANopen structured, a little bit about the history, and to answer those questions, what is the distance of CleANopen to CANopen, to the average usage of CAN, and something like that. I'm the general manager of the CleANopen GmbH, a 100% daughter company of the CleANopen Association, and this means I manage the CleANopen office, and among others, I represent CleANopen also in international standardization projects. So, for example, I've been the project leader for the CANopen communication in the standardization project of accompanying the charging process of light electric vehicles by a CAN-based communication, or I accompanied the standardization process of CANopen in rail vehicles, and among others, I accompanied the standardization process of CANopen in garbage truck applications, so directly the topic we are discussing here. So, in fact, it was a very long process, but with only a little work, only monitoring, because we submitted our CleANopen document in the version 2.0, and then there happened nothing except of waiting, and it took us approximately 10 years, and then we had the EN standard. So a lot of waiting, a lot of pushing, but not real deep technical work there. But finally, we have now this document. So maybe most of you are aware of CleANopen very well, but for those that are not, so CleANopen is the international users and manufacturers group that develops and supports CANopen and other CAN-based higher layer protocols. The non-profit group has been founded in 1992 to provide CAN-based technical product and marketing information. The association fosters the image of the CAN technology and provides a path to future network technologies. So, by the way, the history of CAN has not been written yet. We are still writing on the history of CAN. So, we accompany the development of CAN-FD, CAN with flexible data rate. Let's say technology generation that is currently coming into the market, into the cars and other application fields. And on the other hand, we have now high frequently working group meetings that are discussing already the next generation CAN-XL that allows us to transfer a very large size of data in one single CAN frame. So the objective is to tunnel, for example, Ethernet frames with 2K of data inside. So you see, we are still developing in CAN. The development on CAN has not stopped yet. Of course, we as a user organization, we are keen on your requests. So if you have some CAN-based challenges, then you're invited to come to CleANopen office to submit your questions, to discuss your challenges here with CAN experts in the office, and we try to assist you. Maybe we can do this directly, or we can rely on our social network that we have established since 1992 with a lot of CAN experts focused on certain details in CAN-based networking. So if you need some assistance to accelerate in your project, one good idea can be to contact CleANopen and we try to assist you. We are located, as you see here, in Nuremberg. You can come to our office, or you can give us a phone call, write us an email. So we have also the service of answering technical inquiries. Feel free to contact us how you like, and we try to assist you. Just to underline that CAN is still a very interesting means for solving some challenges in embedded networking. You see here the number of CleANopen member companies. We started in 1992, and we have a more or less constant growth. till today, at the beginning of the year, we had about 703 CiA member companies. So I see for a lot of companies, CAN is still an interesting option for embedded networking, and therefore they also say, well, it could be of interest being CANopen member, having access to the latest news and trends in CAN-based networking. So you see here a little bit the history of CAN in automation. So from the foundation in 1992 with the founding members, Berkhoff, ESD, Geyser, GIN, LP Electronic, MEN, Technology Partnership, and Mr. Holger Salzwanger, who is today also attending this meeting. And here we see CAN in automation has already started in these early days to promote CAN by attending fairs, by doing seminars, conferences, and on the other hand, we try to support the development of CAN, so by writing CAN-based specifications, how to use CAN in an industrial environment, for example, how could a CAN physical layer look like. So these have been first specifications. Then you see CAN automation. This is the place where the CANopen specification is maintained, the document CiA 301. And furthermore, you see that in 2004, people that came together under patronage of CAN in automation, they released the first edition of the CleANopen application profile CiA 422. So let's say a specific flavor of using the CANopen communication profile and application layer. So we still maintain this document. We did further developments. In 2010, we published CiA 422 in the second edition. And as I've already said during our pre-talks, we submitted this document then to CEN for standardization, and we had in 2019 the EN standard EN 16815, the CleANopen application profile for municipal vehicles, as I said, based on CiA 422 version 2.0. In the meantime, we continued our work with our SIG municipal vehicles here in the CAN automation office. We updated the document, we added some functionality, and we released in 2018 the CleANopen application profile in the version 2.1. That you see that also CANopen is a vivid document we released in 2017, also CANopen FD, which makes use of the aforementioned CAN FD, CAN with flexible data rate. So also in CANopen environment, we have now the ability to make use of the increased data throughput provided by CAN FD. So how this will be used in a CleANopen environment, this is still open. Up to now, the working group SIG municipal vehicles said it is not needed for us to introduce CAN FD, but this may change in future. So maybe in some years they will say, oh, it's good to have CAN FD, or maybe in future CAN XL, and then we can have a beneficial use of this new technology. So here you see a small summarization of our current working groups, which are currently active at CAN automation office. So chaired by a kind of steering committee, the technical committee. We have now several interest groups maintaining the classical CANopen, then the new CANopen FD one, looking how does network management, node ID assignment, device description, all these things work now in an enhanced CANopen environment, the so-called CANopen FD environment. And as we support at CAN automation now, not only CANopen, but also CANopen FD, or sometimes even some J9039 based specifications, we have to think, or let's say we have to make the description of the data arrangement within the devices independent from the communication interface or from the style you're using the CAN interface and the CAN communication. So therefore, we founded an IG profile. The interest group profiles is now maintaining that what you know maybe from the former CANopen device and application profiles. We try now to describe them in a way that we have a bus-independent part describing the data arrangement, the resolution of the data, and so on. And then in a second or third part, we describe them the mapping to the corresponding communication technology, CANopen, CANopen FD J9039, or whatever. Additionally, we have the IT lower layers working on the future of CAN, so they accompany the standardization process of CANFD. They are currently developing CANXL and having all these future topics in mind. And finally, we have there also an IG safety security, which works rather slowly, but at the moment they have now a new work item discussing availability of applications, keeping the availability of an application high, and therefore they founded this task force redundancy and to evaluate independent on the used high layer protocols, how can we achieve redundancy, how can we handle bus line redundancy, and they recently started their work, so if you're interested in these issues, then a warm welcome. And finally, we do some marketing at Canon Automation. So also for the municipal vehicle, for the CleANopen profile, we tried to reactivate last year also the marketing with regards to CleANopen. Unfortunately, we had not in mind the impact of the coronavirus and the appearance of the coronavirus, so no fairs and therefore limited marketing possibilities, but I think at least in the second half of the year we can renew this initiative, and maybe you're interested then in joining this initiative and pushing the marketing for CleANopen in a joint way. How this can look like, you see in the small picture where several companies contributed with their single devices or subsystems, and they could show that you can drive CANopen devices up to a level where they really show in a specific application a high degree of plug-and-play capability. So we will have later on in the presentation this picture in a larger format where you see these cable drops, and it was very simple at the fairground that you can say, okay, I want this device, or no, I want to switch from this device to that device, which is from another manufacturer but provides similar functionality, and it was just putting the cable from this device to that device, and so you could demonstrate to the visitor of the fair that there's no additional configuration effort needed, that you have a high degree of plug-and-play functionality. So up to this level we can drive joint marketing activities. Sometimes it's a little bit lower, maintaining a common website in maybe several languages, going to certain fairs, events, and promoting why it is reasonable to use CleANopen, a CAN-based solution, in this application field of municipal vehicles, refuse collection vehicles. Yeah, so what Canon Automation is doing, you see here on this slide. So our mainly business is maintaining the Canon Automation specifications. On the other hand, we have to do for them some marketing and some explanation. So therefore, we offer also technical services, consultancy services, seminars, and so on. So services, technical oriented, marketing oriented for system designers and device manufacturers. Canon Automation serves also as neutral platform for experts from various companies, that they can meet together, exchange their experiences, share their latest developments or challenges and how they solve them. And a good platform for this is the International CAN Conference. The International CAN Conference has been postponed from the last year as it was hit severely by the COVID pandemic to June. This year it has been shifted to a pure online format, and it will take place from June 14th to the 17th. So you're very warmly invited to take place. We will have the sessions in the afternoon any day, and we complemented the program by interesting CiA webinars, open SIG meetings, or working group meetings. So to try some, to enable some networking. We have also established some so-called CiA CAN coffees that allow discussing with other CAN experts, sharing experiences, so maybe we meet in this format again. Please keep the date in mind. We have also the possibilities to share information in our publications. You have this in mind, you know this already, I think, just for being comprehensive. And you see, having access to the document, a prerequisite is being CAN Automation member. This is the biggest advantage and key driver for many people, being member of CAN Automation. But in a second step, they find out that also the social network provided by CAN Automation is very, very valuable and keeps them inside the community, and they enjoy having international CAN conference, having contact to other experts, where they can accelerate in their project in case of CAN-based challenges. So, after a short block on CAN automation, we will come now to the core topic, CleANopen. So, what have been the key drivers for CleANopen? So, there had been general requirements. So, the waste management enterprises had been under cost pressure. So, they had high interest to record the amount of waste that had been generated by which kind of customer, so that they can make some invoicing according to the generated amount of waste, or maybe according to the generated type of waste. Furthermore, they had the situation that they sometimes emptied bins free of charge from people that did not pay their bills, so they don't want to do this, to save costs, of course. And another thing is that they want to optimize their tours. So which tour shall the truck driver take to do the emptying of bins in a most efficient way? And therefore, we need some communication between the entities, between the subsystems available on such a refuse collecting vehicle. So there's a need that the different subsystems talk to each other. And the problem in the history was that all these subsystems had been provided by different companies, and these companies did not talk too much to each other. Means these companies offered their subsystems with interfaces which they had in mind, but they were not negotiated with other parties. So this means everybody comes with another interface, with another type of protocol, and having this situation is a mess for a system integrator, for a so-called bodybuilder, to integrate all these subsystems to a properly working control system, to a properly working refuse collecting application. Well, therefore, there was a need for standardizing the communication interface to simplify and shorten the time for system integration and maintenance, and therefore also to reduce the sources for misconfigurations. And furthermore, if you not only negotiate, yes, we want to use the CAN interface, or we want to use CANopen, but also if you standardize the data formats, the resolutions, then you have harmonized data which complements also the connection to a fleet management system. So summing up all these things, we have in mind saving time, efforts, and costs at the end. So, of course, there had been the decision which kind of communication technique should we use. And we are in an outdoor application. We are in an environment which is rather similar than passenger cars have. And in passenger cars, it is widespreadly used. The dominating embedded network is the controller area network, the CAN. So as it has been designed for automotive use, it is very robust, it is very reliable, and it is available from many sources for reasonable costs. And in conjunction with the high-layer protocol CANopen, we have very flexible communication functions. CANopen is very, very scalable. I can scale or adapt the protocol stack to the, on the one hand, to the needed functions and to the provided resources of my microcontroller, and CANopen allows me a high degree of interoperability between the CANopen devices. So therefore, at the end, there was the choice to take a CAN-based or CANopen-based system. And as a result, we had then the CleANopen profile. We have a CANopen-based system described, where we have several so-called virtual devices. A virtual device is a smallest functional unit, and the group said, okay, which functions do have to interact in a refuse collecting vehicle? And they say we need, for example, a lifter unit, we need to measure the weight, we need to wash the bin maybe, we need to identify the bin, from whom is the bin, we need to maybe monitor the footstep. Is there a worker on the rear or not? So we need to compact the waste that we have collected already so that more waste can be put into the vehicle. So a lot of functions are needed. You see here a small summarization. We will come later on a little bit more in detail to some of them. And all of them may need to exchange data among themselves, among each other, and this is our CleANopen application that defines standardized interfaces to all of the other virtual devices. And as I emphasized, we are defining virtual devices here, so you can implement several of these functions in one physical device, but you have still a highly standardized CAN interface to the rest of the system. So this is our CleANopen application profile, CANopen-based, CAN-based, and standardized and available at CleANopen in the document CiA 422. And we have seen here, we have also considered a so-called truck gateway. A truck gateway allows the interface to the J9039 based in-vehicle truck network. So maybe in a garbage truck application, there's the need to request a higher engine speed, a certain hydraulic power or whatever. Then you have the option now to do this in a standardized way, in a simplified way, and especially the integration of the entire body functionality, the garbage collecting functionality is now simplified if you have a standardized interface to the truck, this so-called truck gateway, and we've considered this in the CiA 422 document. So briefly to the history, we have seen these requirements that we have several subsystems, several entities on such a refuse collecting vehicle, and they have to interact, and also others have already seen a need for defining communication interfaces. So, for example, the Bund Deutscher Entsorger, Verband Kommunale Abfallwirtschaft und Stadtreinigung. So some authorities saw the need, okay, we have to find a common language for all these devices. And when we started our activities at CleANopen, we had these activities from BDE in mind and considered the work they did. And we said, okay, but we are a little bit more open. We have then this based on CAN and CANopen, not on IR 485, to be more flexible. And this was then the approach that had been published in a first version in 2003, the CiA 422. So if you ever search for CleANopen, come to CleANopen and ask for the document CiA 422, and we will provide it to you. Typically not in the version 1.0, but in the latest version 2.1, the current CleANopen application profile. As I've already mentioned, CleANopen has been standardized on European level and is there available as EN 16815, and this is based on the version 2.0 from CiA 422. This document is now maintained jointly by CiA members, so if you have any function requests, any comments, please feel free to submit them to Canon Automation. We will appreciate your contribution and we will consider this. Of course, we would also like to welcome you in the working group SIG Municipal Vehicles, where you can discuss them, your requirements, and get in contact with all the CiA members. So you have learned now CleANopen is standardized in the document CiA 422 and maintained at Canon Automation Office in this document. What means this term CleANopen? CleANopen is a kind of logo for the use of the CANopen application profile CiA 422, which specifies communication coherences between electronic control units in refuse collecting vehicles, as well as the exchanged application data. So we are CANopen based. We use CANopen, which is widespreadly used in many application fields, so we can rely on a lot of protocol stacks provided by several manufacturers on a broad range of tool chain. So we don't have to invent something new, something specific for the refuse collecting application, but we can rely on existing tools from several sources. And CANopen, this is the CAN-based communication profile and application layer specified in document CiA 301. And this is, let's say, a special flavor of using CAN, how you like to use the CAN communication, how do you set up the physical layer. So the CAN, how it is specified in the ISO 11898-1 and 2, the data link layer document in -1, -2, the physical layer, considering, of course, the classical CAN, not having in mind CANFD yet. So just for giving you an idea, how is such a CleANopen network layered, structured, or CleANopen communication, we have said everything is CANopen based. So we exchange CANopen communication objects. These CANopen communication objects or services, they transfer application data that is specified according to data type, resolution, and so on in the CleANopen specification. We have there also in the CleANopen specification what are, for example, triggering events for communicating something, which service defined in CANopen shall be used for communicating this or that information. So this is done in the CleANopen specification. We are using things introduced by the CANopen communication profile application layer CiA 301. And CANopen itself, as I said, it's CAN-based, so we are using the CAN data link layer, we're exchanging CAN data frames, and any CAN data frame is then transferred via the CAN physical layer, the high-speed physical layer, allowing data speed, data rates up to 1 Mbit. You see here the summarization, where is the CleANopen physical layer specified, ISO 11898-2. We are finding the physical medium attachment with regard to the bit timing. The basic rules are given also in the ISO 11898-1 in this time, together with some rules from CANopen given in the CiA 301 and some specifics in the CiA 422. We will have them on the next slide. And we give also some general recommendations with regard to connector pin assignment, cables, and topology. The CleANopen specification has in mind that we are running on 250 kilobit. So this is our communication speed, but CleANopen does not close the door to use other bit rates introduced by CANopen. So you see here in this table the CANopen bit rates, and the yellow line is that one which has to be supported and is used by default in a CleANopen environment. So in CANopen, we have the obligation that every CANopen device has to claim a network-wide unique node ID, a 7-bit coded value. CANopen itself does not specify how you assign a certain node ID value to a specific device. So there exist several types how you can do it. You can program it directly in the firmware. You can do it by local switches. Some connectors can have additional pins which can be used for assigning a node ID, or you can use layer setting services or whatever. CleANopen is there rather vague. CleANopen gives you no additional rule how to assign a node ID value to a specific device. But CleANopen gives you a kind of allocation scheme, which device should provide which node ID value. So it depends now which virtual device functionality you are going to implement in a device. Then you can look or go to this lookup table and say, okay, I've implemented, for example, the lifter unit 1, so I will provide my device with a node ID 20. So in this way it works, and this allocation scheme shall ease once again system integration, that everybody who contributes to a refuse collecting vehicle can directly see, okay, which node ID should I provide on my device, and then there's, at the end, in the best case, no node ID configuration anymore needed in the times where system integration takes place, because every device comes already with a correct and intended node ID value. CleANopen data link layer, as I said, it's CAN-based. We are using the CAN data frames in a classical format. I think no need to say there lots more. And the way we are using the CAN frames, we see here it's according to CANopen. For the newcomers here, CANopen has been pre-developed in 1993 in a European research project and has been then handed over to Canon Automation for maintenance and further development. So you see here, since September 1995, we are maintaining here the CANopen specification in the document CiA 301. Of course, no longer in the version 2.0, but in the latest version 4.2, available to the public since 2011, and also standardized on European level in the EN 50325-4. As I've already said, we have already an edition that can make use of the CANFD data link layer. It's the CANopen FD, available in the document CiA 1301 for Canon Automation members. Well, how does now CANopen and CleANopen are related to each other? We see here CANopen is not a single monolithic document, but CANopen consists of an entire profile family. The basic functions of CANopen, the device architecture and the basic services, they are provided in the document CiA 301, but we can differentiate between two document ranges, the documents in the range 300 and the documents in the range 400. In the range 300, we are finding the communication rules and extensions to the basic communication profile. And in the range 400, we are finding the specification of the data that we are going to communicate in a specific application field with the means introduced by CANopen. And we find here our document CiA 422, which defines the data for the application field refuse collecting vehicle and tells us how to use the services provided in CANopen in this specific application field. Furthermore, I highlighted here some documents that might be of interest: how to do network management, CiA 302. If it's needed, dynamic node ID assignment, then you will here find in CO5 the layer setting services. Of course, you need a text-based description of your devices so that tools, controllers learn what is the provided CANopen functionality. It's the electronic data sheet, and CiA 413 defines the interface to an in-vehicle truck network it's the so-called truck gateway specification, interbreeding between the world of J9039 and CANopen. So briefly, CANopen, how does a CANopen device look like? If you have just a CAN device, you have no clue where is data coming from, or that is communicated, or if a device receives the data, where is the data going to into the device? Or if I generate here at the so-called process interface some data, maybe because I have here a sensor, I have a metering chamber, and the sensor wants to transmit the data now via CAN. How to bring the data on the CAN, I have no idea, or if I shall get the status of this CAN device, I have no idea if I haven't read the specific manual and the manufacturer-specific services that are provided to get the access to this information. As soon as I know that it's a CANopen device, this internal device architecture appears, that is mandatory for any CANopen device. I have the structure that I have a piece of software running the CAN communication in the intended way, because in the way as it is defined by the CANopen specification 301, where I have two services for the data transport, the RPDO and the SDO, and a broad range of services that is more or less related network management. On the other hand, I have a piece of software that is running the device functionality, the application software, the core competence of the device manufacturer. And both software entities may have to exchange data. For example, my generated process data, I want to communicate on the CAN side, or vice versa. I want to give some set point values or start commands, process initiation commands here from the CAN to the device application. How can these two software entities exchange data? Therefore, we have a clear device internal interface. It's the object dictionary. In the object dictionary, I find all my parameters that are necessary to control the entire device, the communication parameters determining how does a device operate at the CAN interface, and the application parameters that determine how does the device behave on the process interface. And the CleANopen provides us here a broad range of standardized application parameters that allow us a standardized control of the device functionality, and provide here at the CAN interface a high degree of plug-and-play functionality. The CANopen object dictionary is typically the heart of every CANopen device, and as I've said, we have here three major ranges: the communication parameters, manufacturer-specific parameters, and the standardized parameters. And these standardized parameters in our use case are now defined by the CleANopen specification. CleANopen says, okay, here's the standardized data that you can now communicate with the means of CANopen. Of course, besides this, you have also the option to run manufacturer-specific functionality, but I like to emphasize the other possibility now, this standardized profile area, because this is our aim to increase the degree of plug-and-play functionality of our devices. The more you introduce manufacturer-specific functions, the more configuration effort will be needed at the end of the day, and this is what we want to avoid. For those that are not that familiar with CANopen, just a small idea. In an object dictionary, we refer to any data element by an index and sub-index, so we can maintain up to 65,000 data objects, which can support each up to 255 data elements. So we have, in theory, a big pool of data cells available, and it's now up to the different specifications to fill these data cells with meaningful data, with standardized, harmonized data. And we see here one example. It's the device type object 1000, which is, by the way, mandatory for any CANopen device. And in our use case, once again, we can read this, and we will discover here the value 422. This is the number of the application profile of the CiA document, where this application profile for refuse collecting vehicle is standardized. And in this example, we see we have there, or in this 32-bit value, the upper 8-bit that provide us with the information which virtual device with functionality is implemented here. Do we have here a body controller, a change container unit, a compaction unit, or whatever? So, by the way, you have also the possibility to implement several of these functionalities. Then there's an additional parameter available in our object dictionary that assists us in providing and indicating all the implemented functions. All the CANopen services are available to communicate our CleANopen data. So I highlighted here those services that are of special interest. So of course we need the service data object for configuration and diagnostic tasks to access any data element and any device, being able to get all the information we need. Also, for example, for fleet management systems, this is of high interest that I get all the data elements which I want at the end to report. On the other hand, we have the process data objects. During system runtime, they exchange the process data which keeps the entire application running in the intended way. Then we have some special objects, like for example the emergency messages, which report if there's something going wrong and which kind of errors have been occurred. On the other hand, for bus load management, we may need the synchronization protocol. And mandatory for any CANopen device is to support the network management. So we have a network management state machine. I have to control my CleANopen devices in the state machine, and I want to monitor whether they are still available. Therefore, I have the error control protocols such as the heartbeat protocol. So we don't have a CANopen webinar here, so therefore just roughly that you see SDO allows us to set up a point-to-point connection between two CANopen devices. I can exchange in a confirmed way data between an SDO client and SDO server. This is the terminology we are using here for these two devices, for the requesting device and for the requested device. So the requesting device, the client, can read or write data here in the server. This is in CleANopen environment maybe of interest. If you generate data, if you measure data, and you have to write for reporting service, for data acquisition, now the measured value together with a bin ID, together with some other surrounding or additional data in one set to the data acquisition system, then the service data object could be of high interest, and it will be the option to report this. So if you're talking about service data object, please keep in mind that one SDO connection determines who is speaking with each other and who is the client and who is the server. This means for this we need for every SDO communication coherence in CANopen. So if two other devices shall speak with each other, then we need two additional CAN data frames with two new CAN identifiers. CAN identifiers have to be assigned uniquely in a CAN-based network, so they have to be different to those we are using for another communication. And then we can set up this new communication channel, so please have this in mind when you operate in CleANopen. There are specific use cases where you would need several SDO server channels in your devices. Briefly, in an SDO, you transfer the data. The most often used CANopen service, I would say, in configuration and diagnostic task is the SDO, and therefore, if you transfer data that is not larger than 4 bytes, which is typically the case, then you have the Expedited SDO protocol, where you can directly, in the initiation frame, transfer the data. So you just send 2 CAN data frames for transferring the data from the client to the server, or vice versa, depending if you read or write here between these devices. So The other mean for transferring data, especially for transferring process data, and which is the base for running system typically in CANopen as well as in CleANopen, is the process data object. And here comes now the CleANopen specification, specifies the data content for all these virtual devices. What is the process data which they generate? What is, for example, the measured value? What is the status of the lifter? What is the command for the washing unit and these things? And CleANopen says, okay, how is the data assembled in such a so-called process data object? And you see, CANopen in general allows us to define up to 512 process data objects per device in receive and transmit direction. One PDO always determined by two parameter sets, the communication parameters and the mapping parameters. So just a very small example where you see here our communication parameters and the mapping parameters for one example PDO. You see, according to the CAN identifier, you identify, okay, here I'm dealing with this first RPDO, so it's the 181, this is my CAN identifier, and according to the mapping table which is provided in these indices, we can learn how to interpret the data. And this entire mapping table, this is also predefined by CleANopen now in our use case, which is of interest today to discuss the CleANopen specification. So the CleANopen specification defines the data content in my object dictionary as well as the mapping table for these process data objects, also the CAN identifier which is used in the triggering event to achieve cross-communication between predefined intended cross-communication between my devices in my refuse collecting application. So another extension to the basic CANopen specification we find here in the emergency protocol. So CANopen provides us the emergency protocol, but the CleANopen says we do not only provide an error register indicating that with this device there's something wrong and some emergency error codes indicating that we had troubles in processing a receive PDO or that we have troubles on the CAN bus. No, we have here also the possibility to indicate which kind of virtual device had some troubles, had some problems, and this we do as we use an additional byte here in contrast to the, let's say, generic emergency protocol provided in CiA 301, and we provide here the so-called virtual device code, a code which is related to the specific virtual devices. And we can indicate here the body controller, the compaction unit, lift number 4, whatever has some troubles. Yeah, and finally, not forget, we have in CANopen the network management state machine. And here you should know, if you are not familiar with CANopen too much, you have here the ability to switch a CANopen device into several network states where you can say in pre-operational, I can configure my device, I can verify the configuration prior to putting the entire application into service. I have the operational state where my entire refuse collecting application is running. And the contrast to this is the stop state where I switch more or less in a logical way the CAN interface off, and there's almost no communication possible anymore with this device. And with a network management protocol, I can switch my device in these network states. I can initiate state transitions to maintain a single device in the state machine and my entire refuse collecting application. So based on all this, the only thing what CleANopen is doing is defining which application data is needed, and this we do, as we said, we have several functionalities like the body controller, which provides the interface to the truck where I can demand hydraulic power, where I can demand engine speed and so on. We have a bin classification unit, we have the container change unit, the compaction unit. We can identify what's up with the footstep. Is it in a position where we are operating and we are refuse collecting, or is it in a position where we can move on the road to move to the next dumping station or so on? We have a GPS unit, we have the identification unit, we have an extension for the body controller, it's the body controller input-output unit. We can have several lifter units, of course, measuring units, and the already mentioned truck gateway unit and the washing unit. And for all of these functionalities, we define the process data, we define how this process data is then communicated, and therefore we define intended cross-communication between these virtual devices. Me as a subsystem manufacturer, I have now the degree of freedom to say which kind of functions do I like to support. I can implement them, and of course these functions that are implemented in my device, they can communicate via the local application, but to the rest of the system I maintain still a communication interface with a high degree of plug-and-play functionality. So you see here, we define then for these virtual devices a lot of parameters, but first we started with some general physical parameters, where I said, okay, please provide which kind of virtual devices are supported, which profile version has been implemented, and for all of these devices could be valuable information about the work hours, absolute daily, so that we can provide this information maybe for fleet management systems. A major part of a refuse collecting vehicle is the lifter unit. So the lifter unit provides information about the dumping process and controls the process itself, start, stop, fast, slow, and so on. So the lifter unit is able to apply only one bin. Lifter functionalities and features, we can have up to 8 lifter units per network supported. We provide the lifter unit positions, we count the number of emptied bins, we can request engine speed, and we configure the speed and the measuring position. So how does this work? So let's start first with the inside of the configuration. So we are rather flexible in our setup. So we can have a single lifter, but we can also have several lifters, and they can operate in a combined mode. So according to this concept, we can support with our CleANopen profile, I think, all the refuse collecting vehicle configurations that are out there on the streets. You see here, for example, we can have on the left side, on the right side, combined lifters, single lifters, and we can also have front loaders, rear loaders. So, as I said, very scalable, and we can support any kind of configuration here that is out in the field. This is just a small subset. There are much more configuration possibilities supported by CleANopen as depicted here in these 2 slides. Then, for going on, it's important to understand how is the functional interaction. Which kind of process have we described here, or do we support via the CleANopen profile? So the process that we have in mind is that we approach a bin. The first is we have to identify the bin. Is this a bin that you want to empty? Yes or no? Is this from a customer, maybe that is from you, or is it from a neighbor and it's not really your customer? And so you can identify the bin, and is this according to a customer that they want to empty. Furthermore, you can identify maybe by a text also the content. So maybe is this the bin for paperwork? Is this the bin for metal? Is this the bin for other things? So also this is possible via the identification unit. If you're clear that you want to empty the bin, then you can give the command for the lifter movement when the bin is applied. And then you have to define a measuring window. In some cases, you charge your customer according to the generated waste. So therefore, you have a measuring window, you measure the waste, which you are, or let's say you measure the entire full bin, then you're emptying the bin, and in the way down, once again, you are measuring the bin, and therefore you know the tare value, you know what is the weight of the bin, and therefore you can calculate what was the value of, or the weight of the waste you have now collected. And this you can charge then to your customer. So this is the process that we have now in mind in this CleANopen profile. And you see this here, we provide here the possibility to define the range, the lifter from the base position 0% to the maximum position 100%. We can define now in this percent of the movement angle where is my measuring window and where shall the measuring take place. We have here all the parameters needed to define the lifter speed. As it was already mentioned in the pre-discussion, the speed definition is a little bit different to that you may know from other CANopen specifications like 402. We say we have the speed in percent, the position in percent, and then we define at which position we want to achieve which speed percentage. And then you can therefore generate such curves as we have here, defining the movement and the speed of your lifter. And thus you have a big table of parameters for the lifter, providing all the valuable information that you need to configure your lifter in a predefined way, and all others in the system can rely on this information independently, whether they have already in advance of the project contact to you or not, because you follow the CleANopen specification, which is available at CANopen and available to the public, so everybody knows, okay, if I have to contribute to this, I know exactly what to support, and I have a high degree of plug-and-play capability. So here you see some other parameters, how they are defined. As I said, lifter position in percent, you have a bin counter, you can count just the bins here per day or in whatever time distance or per tour, or you have the absolute counter, so this is available. Just for giving you a little bit deeper insight to the parameter definition, for example here for the lifter, we have here this 16-bit value identifying the lifter status, indicating that the lifter is ready to work or not ready to work, that the lifter is active or not, is currently moving, or the way he's moving, is moving down, it's moving upwards, has reached a certain position. So this provides this upper part of the status. But in this business, such lifter units may do some combined action. So for example, depending on the lifter action, there's some other activity needed. For example, we have to initiate the compaction unit, we have to initiate a washing unit, and these things. And in the status, we find already this information. So you see here, depending on the lifter status, we can enable the washing unit. So for example, when the bin is now emptied and still in the upper side, then we want to wash the bin. We have a certain lifter status where we can start the compaction unit, and we can also monitor whether the bin is correctly applied or not. So you see, everything is here provided in this lifter status. As I've already mentioned, the bin identification unit allows us to identify Is this a bin we want to empty? Has the bin not only the correct owner, it is a customer, but is there also the correct content inside? It's done by the identification unit, and only if everything is correct, then we give the indication to the lifter, okay, you can do the lifting, or if we detected, there's something wrong, then we can pause or stop the lifting process. As already indicated, for some actions we need some engine power, some operating speed, the hydraulics, and here we have expected a gateway in the body controller, but it's not always provided like that. We have two solutions. We have defined the truck gateway unit, but the truck gateway unit may be directly integrated in the body controller, and these options we have also considered here in the CleANopen specification. You see, the body controller provides the interface to the hydraulic and the pneumatic power supply of the refuse collecting vehicle. Related to the operating mode, other units may request the supply pressure from the body controller. So just that you see how another structure could look like for requesting data. That is a very typical structure that is used in this document for requesting the operating speed, hydraulic supply, or to indicate the truck drive position. This you see here on this slide. This we have already mentioned, that we can have several implementations. We can have an independent truck gateway, a truck gateway that is, for example, provided at Iveco trucks, and which simplifies enormously the integration of superstructures on a chassis, or it can be directly integrated in the body controller. The entire thing what I've introduced to you is not just paperwork, it's out on the road, it's implemented by several customers. You will find several companies contributing to this, providing subsystems. And there had been also an IFAD fair where we had a nice demonstrator where you see these open drop cables, and you had the same functions implemented in a redundant way, that you have different companies providing the same functionality, and live at the exhibition you could say, okay, I disconnect this device, connect that device with the same functionality, and you could demonstrate the high plug-and-play functionality. Well, this brings me to the end of this webinar. Summing up, CleANopen CiA 422 is CAN and CANopen based. So this means we can rely on the big available CAN and CANopen tool chain, on the widespread sources that we have with regards to the CAN-CANopen market. We don't have to invent the wheel new. CleANopen enables interoperability of devices or even entire subsystems of refuse collecting applications. So this leads to the fact that we reduce the effort for system integration, that we save time for system integration. And as we have standardized data formats, standardized data in our object dictionary now, harmonized data formats, this assists fleet management systems enormously. And as I've already indicated, the CiA Special Working Group Municipal Vehicles maintains and enhances CiA 422. So therefore, my wish and my invitation to you, get in touch with other players in this application field, attend the next SIG municipal meeting. For example, as a guest, you can participate and see what's going on, get a deep understanding of CleANopen, submit your requests, discuss your feature requests, and do some social networking to accelerate your future projects. When you will have the next meeting, you will see on our regularly updated website, www.can-cia.org, groups, technical-groups. Yeah, so far from my side. Furthermore, this group intends to have plug fests, so doing interoperability tests. This will be one of the next steps, I think, when Corona pandemic is hopefully over soon, then we are going to renew these activities. So if you want to be part of these activities, then please stay in contact with us, and we would like to welcome you and would appreciate to welcome you on one of our next events. So I'd like to indicate our CiA email services for staying regularly updated. You find the CANinfo mail and the CiA member news. The CANinfo mail provides regular information on latest trends and developments in the CAN application field. The member news provides latest news from the CiA community. Hopefully, in not too far future, there will be on-site events possible again. So we hope at the end of the year that we will have the Interlift, the Agritechnica, and the SBS fair. So latest at the Bauma fair, maybe you will be available, and we can have direct talks, or maybe on one of the others, I don't know. And we see the CleANopen webinar today was not our only webinar, so we have further webinars planned this year. So you see here we have it also in different languages. So depending if you have colleagues preferring a Russian or Chinese style, then you could hit them on these webinars, and we would appreciate to welcome them on one of the next events. Last slide. If you enjoyed this webinar, and if you think it's valuable, or if you have some remaining questions which you don't want to place now but maybe later on, please feel free to contact us, to follow us in the social media. Goodbye. Thank you for attending the webinar, and I hope I can meet you once again in person, and stay healthy and have a good evening. Thank you very much. Bye.